Now, if you use the idea of this, as I went through just now, in order to attain a zero new resultant force, where must the other force be such that it will cancel away this 10? Friction. So how much is the friction?
10.
Okay, so this is the next common question. They will tell you object is moving with constant speed, the pushing force is 10 newtons, what is the frictional force? Immediately, you don't even have to calculate, the answer is 10. That is based on our conceptual understanding. Okay, that's not based on some trick, it's just understanding.
Oh, the friction is 10 newton. That's why the resultant force is.
The friction is 10. That is why the resultant force is 0. That is why there is no acceleration. That is why the object is moving in constant speed.
Why there's no force?
If there's no force, what happens when there's no force?
The ball can move.
It won't move, yes. Because there's a friction of 10 newtons acting on it. In order to start moving, you need to have at least. Okay, let me give you a new example. Thank you for asking that. I have a box on the floor as well. It is at rest. It's not moving. Now, assuming that it has already a frictional force acting on it, without even moving, it already being stopped by friction. Now, can you imagine your ground without friction? Do you think your objects will stand still?
No.
You'll start to slide here and there. Okay? So friction, in this case, there are two kinds of friction which you will not learn, but I just let you know, this is called a static friction. Okay? Now, what is the minimum amount of force you need to apply such that it will start to move?
10.
You need anything more than. As long as it is more than 10, your resultant force will not be 0. Even if it's 10.000000001, it is still bigger than 10. And it will start to. So the misconception here is most of you think that it must be 11. Your answer is not wrong, but you are limiting yourself to just one number, which is wrong.
More than 10.
It must as long be more than 10, you are good to move. Okay? Now, the last one is Newton's third law. Now, Newton's third law is a little bit more complicated, but we will water it down. We will water it down to. Actually, whatever you learn is not very conceptually right, but I'll just use an example. Okay, now I have an object hanging on a thread, right? A pendulum, for example, or maybe just a heavy ball.
It won't move unless you enter the box.
Okay, good. Now, first of all, let's identify all the forces acting in this system. What are the forces present in this system?
Gravity.
Gravity is not a force. Gravity is a pull. It's a naturally occurring phenomenon. Weight is the force. Weight must act from the center if it is regular, right? Now, as you remember, in Newton's first law, if this object is at rest and I have a weight pulling it down, what must be present? Think of it. It is at rest, but I have a weight pulling it downwards. What else must be present? I have zero resultant force. I have zero resultant force. But right now I have a downward pulling force of 10 newtons. What else must be present in this system? Opposite which direction? Upwards. Where is it?
The pressure.
It is the tension in the. Okay, in this case, we must be very sure that my tension must be exactly the same as my weight.
Why?
Now, ladies and gentlemen, this is something similar to Newton's third law. For every action, which is the weight, there must be a reaction. Something similar. I'm not saying the exact one because third law is not so easy to understand.
Is 9 Newton, the pendulum will drop.
Yes, thank you. If my tension is anything less than my weight, right, what will happen to the ball? Drops. If my tension is more than my weight, the ball will move upwards. Moving up. Okay, quite simple, isn't it? Almost done. And in my book, we use the idea of an aeroplane. So if I would just draw a very ugly drawing aeroplane, I have no idea what.
Is it from side view? That means the wing is like up and down.
Yeah, I must draw an engine. Aeroplane is flying in the air, is cruising. Is moving this way with a forward engine thrust. Okay? Now, can you imagine you are the aeroplane flying in the atmosphere? What is opposing you?
Air.
Air resistance, right? Okay. Now, tell me, what else is missing in the picture?
Gravity.
Weight of the plane.
Are we supposed to
Okay, guys. Can you tell me what is the relationship between this thrust and the air resistance? If the plane is moving to the left, what is the relationship between the plane thrust and the air resistance? My question is asking basically which must be larger.
trust.
Agree? Obviously, right? Or else the plane will move backwards. I never see a plane fly backwards.
To save you.
Thrust must be more than air resistance. That one is quite clear. Now, guys, something is wrong with my picture. Have you seen the plane flying and it's dropping?
No.
As it is cruising in the air, do you think it is flying and it's dropping at the same time? No. It is usually flying at the same altitude, height. So it is flying at the same height. Something is wrong with my picture.
Constant speed. Isn't friction air resistance?
Air resistance is a form of friction. There must be some kind of upward force. True? Or else the weight will keep pulling the plane. But what is this upward force? Okay, don't worry, you don't know that. It's called a lift. It's called a lift. It is the lift provided by your wings. It is basically the air that is pushing the wings up. That's how birds fly. They flap, they are pushing the air downwards, they are going upwards. Okay? So if the plane is moving at the same altitude, the same height, what must be the relationship between the lift and the weight? Equal.
But in order to fly high, the lift must
In order to fly high, the lift must be
more than the
greater. In order to descend,
The weight must
the
be
lift
less.
must be
More.
lesser. The weight can never be more because the weight is fixed.
Oh yeah.
You don't start throwing people off the plane. Correct? Your